Welcome everyone. This is my first YouTube video. I want to discuss the beauty of science and physics. Actually, I am invisible because I do not want your attention on me. I want your full attention on this paper so that you can understand fully the concept of physics. I want to discuss from basic level to the advanced level in step by step. So let us start with scalar and vector quantities. Now, first of all, you need to understand the physical quantities, which are called physical quantities. The physical quantities. Suppose this pen having length, also having some material in this pen, it's called mass. Also have surface area, volume. So all these need to measure. Volume need to measure, surface area is the measurable quantities. These quantities, length, mass, volume, surface area, all this called physical quantities. Also the velocity, force, acceleration, time. All this, whatever we need to measurement is called all are physical quantities. These physical quantities are classified into two categories. One is scalar. Another is vector. So, scalar quantities, those having only magnitude, not direction. So, we are already studied in our class from nursery to the metric level. We have also know about the addition, subtraction, multiplication, division. All these are scalar quantities. Already we have know about in your mathematical problem. All are you have done scalar quantities. Suppose 5 gram mass, the mass of this pen having how much material present in this pen. So this is called mass, the amount of mass in this pen. Also if we add another pen, the sum of two mass is just scalar addition. Let us consider 2 gram mass in this pen, another is 5 gram, adding this to is 7 gram. So this is scalar addition, scalar subtraction. 5 gram minus 2 gram equal to 3 gram. If we subtract 2 gram mass from a 5 gram body is 3 gram. This is scalar subtraction. Also 2 into 3 is 6, what we have calculated in our previous academic year. So all these are scalar multiplication, also scalar division. So this is already you have done in your metric level up to. Now what is special in vector? We have discussed vector in details. Now vector quantities are those quantities having magnitude and direction. Suppose force is a vector quantities. What is special on force? Consider a pen. If we apply a force along this direction, then pen will move along the force. If we apply another force in the opposite direction, the two forces can be cancelled if they are equal. If one force is greater, then the greater force will give the resultant force, resultant direction. So how can this understand? Suppose a box, if you applied a force F1 along this direction and another force F2 along this direction, suppose F1 equal to 10 Newton and F2 equal to 2 Newton, then block will move the resultant direction, resultant force. The resultant force means the 10 Newton force, 2 Newton force. In case of vector, it's having magnitude and direction. So if you take in the direction is positive, then the opposite direction will be taken as negative. So F1 resultant force F equal to, it can be represented by F vector, F1 vector plus F2 vector, resultant force of F1 and F2. So in case magnitude, F1 10 Newton and F2 2 Newton. but it is negative because in the negative direction it acts along the negative direction, and F1 acts in positive direction. So 10 Newton plus minus 10 Newton, this negative sign indicates the direction. If you take in the positive direction along this direction, then negative will be taken in the opposite direction. And in this case, remember, the negative signs will come as direction. So 10 Newton minus 2 Newton, 8 Newton force. If F2 equal to 10 Newton, suppose 2 Newton no, 10 Newton, then in this case, resultant force 10 Newton plus minus 10 Newton. Then 10 plus minus 10 will cancel each other, 0 Newton. That means these two forces equal and opposite will cancel. So resultant force 0. If 10 Newton force, if both force along this direction, 10 Newton, both force acting along the same direction, then both are positive. So in this case, resultant force equal to 10 Newton plus 10 Newton, total 20 Newton. So we have seen that equal force 10 Newton act in the same direction gives the result 20 Newton, and act in opposite direction gives the result 0 Newton. So vector quantities force is vector because it depends on direction. So in case of addition of vector, that direction also consider. So vector can be represented by an arrow sign, where magnitude is A and direction can be represented by the arrow. In this case, we can represent A dot A cap. Generally, a vector can be represented by A dot A cap, where A is the magnitude and A cap is called its unit vector. This unit vector is nothing but a unit magnitude vector, only represents the direction of A cap, A vector. So A cap can be represented by A vector divided by magnitude. This is important formula to find the unit vector. A vector can be represented by a vector. So an unit vector A cap equal to A vector divided by its magnitude. Magnitude can be represented by mod of A. A can be represented by mod of A. It's called magnitude. So if you graphically represented A by an arrow sign, this is called A vector. If you multiply A by 2, then 2A will be represented by double of this line. This length represents the magnitude of A. Then 2A represents its double of A length. 3A represents triple. But direction same. That means a same direction. So multiplying by a scalar is not alter its direction, but magnitude will be multiplied by 2-3 times. And we also represented by the vector in one-dimensional coordinate, two-dimensional coordinate, three-dimensional coordinate. Now representation of A in one dimension, suppose x-axis 0 to x. In this x-axis, if you consider a point P where x equal to 4, then remember along x-axis unit vector is called I cap, along y-axis unit vector is j cap, and along z-axis unit vector is called k cap. So along x-axis, suppose we can represent it by x, y and z. Z means perpendicular. X, y on the paper, plane of the paper, and z means perpendicular direction. So along x-axis unit vector is I cap, along y-axis unit vector is j cap, and along z-axis unit vector is k cap. Remember this unit vector direction. So a vector 0 to O, O to P, we can be represented by OP vector. Let us also consider this a vector. This is no problem. And we can represent magnitude of OP 4. Then 4 into direction of unit vector I cap. So we can represent this vector OP by 4 I cap. and with 3, if we represent a vector up to 3, then we can represent 3 I cap. So along x-axis we can represent a vector equal to generally x into I cap, where x is the value of the point, coordinate point. Similarly, along 2 dimension, in case of 2 dimension, there are 2 coordinates, and you have x and y. So a can be represented by a point P, x, y coordinate. That means x along x-axis this distance and y along x-axis this part. So along this x-axis we can represent vector xi cap, and along y-axis we can represent it by vector yj cap along this direction, j cap direction. So that vector can be represented by magnitude into direction. So along 0 to may be represented this point at as q. So 0 to q xi cap, 0 to q vector xi cap, and q to p vector y j cap. Then op equal to 0 to q plus q to p, 0 to q plus q to p. This is also called triangular law. We can represent it by triangular law, or equal to x I cap plus y j cap. A vector equal to x I cap plus y. This is 2-dimensional representation of vectors. In 3-dimension representation, we can write x-axis y and z, or suppose sometime along the direction y and the perpendicular direction we have taken the z. This is xy, this on the plane of the paper along x and y, and the z direction perpendicular to the plane of the paper, z direction. So if we represent a vector and the point P can be represented by x, y, z, that means along x-axis it will go up to x, and vector can be represented by x I cap. Then along y-axis it will go up to y j cap. Then perpendicular to the plane z-axis to the point P, it can be represented by z k cap. So total O to P, OP vector equal to sum of O, suppose this point is Q and this point is R. So OP vector equal to OQ vector plus QR vector plus R2P vector equal to x I cap, y j cap plus z k cap. This is 3-dimensional representation of vectors. So we have here discussed the 1-dimensional representation of vector, 2-dimensional representation of vector, and 3-dimensional representation of vector. Now we want to find the unit vector of a vector. So in case of 1-dimensional representation, we know the unit vector a cap equal to a vector divided by mod of a. So in this case, a vector means x I cap and its magnitude x equal to I cap. So in case of one-dimensional case, okay, that means unit vector only along x-axis. So a cap equal to I cap. In 2-dimensional representation, we can calculate the unit vector a cap equal to a vector divided by its magnitude. Now remember, magnitude we also already know how to find the magnitude for xi cap plus yj cap. This is the vector and its magnitude root x square plus y square. So this is the unit vector in 2-dimensional case. And in 3-dimension case, we can calculate the unit vector a cap, a vector divided by its magnitude, x I cap, y j cap, z k cap divided by magnitude of a vector equal to x square plus y square plus z square. This is three-dimensional representation of vector. This is how we can find the unit vector along 1 dimension, 2 dimension and 3-dimensional case. Now let us do some numerical problems on unit vector. Suppose a vector 2i cap plus 3j cap plus 6k cap. To find the unit vector of a cap for a vector. So we know the formula. Unit vector formula a cap equal to a divided by mod of a. So just substituting these values, 2i cap 3j cap plus 6k cap divided by mod of a, 2 square plus 3 square plus 6 square equal to 2i cap 3j cap plus 6k cap divided by just summing all this value 4 plus 9 plus 36, and we get the unit vector of a cap. Now if we further consider a vector equal to, this is example 1, and example 2, if a vector equal to just 2i cap plus 3j cap plus k cap and b vector equal to I cap plus 3j cap minus k cap. Suppose these two vectors. Now to find the, if you like to find the unit vector a vector plus b vector and a vector minus b vector. Now these two are also vector, a vector plus b vector also vector. So if you need to find the unit vector of a vector plus b vector, then we can write r1 equal to a vector plus b vector and r2 vector equal to a vector minus b vector. So how can we calculate this? r1 vector, very simple, b vector, just summing 2i cap 3j cap plus k cap plus b vector I cap plus 3j cap minus k cap. Then in this case I cap component will be add with I cap. So there is 1 and 2, 3i cap and 3j plus 3j 6j cap and plus k cap minus k cap 0. So this is a vector plus b vector, and to find the unit vector of a same formula, the general formula is a cap equal to a vector plus b vector divided by mod of a vector plus b vector equal to 3i cap plus 6j cap divided by root 3 square plus 6 square. In this way, same way we can also find the unit vector of a vector minus b vector. R2 vector a vector minus b vector equal to 2i cap plus 3j cap plus k cap minus I cap plus 3j cap minus k cap. So 2i cap minus I cap, 2i cap plus 3j cap plus k cap minus I cap minus 3j plus k cap. We can write 2i cap minus I cap and 3j cap plus 3j cap 0 plus k cap plus k cap 2k cap. So this is a vector minus b vector, and to find the unit vector of a vector minus b vector, same formula, a cap equal to vector divided by its magnitude. This is the general formula to find the unit vector mod of a vector minus b vector. So I cap plus 2k cap divided by root 1 square plus 2 square. In this way we can find the unit vectors of any vectors. Now here we see how to find the angle between two vectors. Suppose one vector acting along this direction, a vector, and another vector acting along this direction. So what will be the angle of AB? if you select this is the angle between them, then it will be wrong, because in this case you need to connect the tail of both vectors. This b vector can be redrawn as same length, and the tail of two vector will be connected at same point. Then this will be the angle theta. If another way, we can consider a vector and b vector along this direction, then this will be the angle theta. So moreover, suppose x and y axis, suppose two vector, a vector acting along this direction and b vector act along this direction and c vector act along this direction. So what will be the angle makes an angle with x-axis? In this case, A makes an angle with x-axis theta 1 along x direction. A makes an angle theta 1. But what will be the angle of B? In this case, B will extend it along this direction. So the tail of B will touch at this point, and in this case, this is theta 2, the angle of B with respect to the x-axis. And what will be the angle with respect to C? So angle between C and x-axis will be, this is the angle between C. Always angle positive in anti-clockwise direction with respect to the x-axis. So when we measure an angle in anti-clockwise direction, then it will be positive angle. And whenever you makes and measure an angle in negative direction, suppose this theta 2 will be negative angle. So the positive angle we can redraw as the angle with respect to the positive x-axis made by B. In this case, we can select in this anti-clockwise direction. Then suppose this is theta 4 total angle, and we can write theta 2 equal to 360 minus theta 4. That means, so we can tell, suppose theta 2 is 60 degrees. So what is the angle makes with respect to the x-axis? Angle by B vector makes with respect to x-axis. So in this case, we can say that this will be the angle theta 4. Theta 4 equal to 360 minus theta 2. 360 minus 60 degrees equal to 300 degrees. So angle makes with respect to the positive x direction by B vector is 300 degree, not 60 degree. So in this case, you can say that it will be minus 60 degree, either 300 degree or minus 60 degree. Consider there is a large number of vector acting on a point. One vector f1 along this direction, another vector f2 along this direction, another vector f3 along this direction, and f4 along this direction. Then what will be the angle between f1 vector and f2 vector? So in this case, f1 vector along this direction from 0 point to this along this, but f2 along this. So f2 will be extended along this path. So angle between f1 and f2 will be theta 1. This will be the angle. And similarly, f3 will be extended along this path so that their tail will be connect at a point. In this case, both f1 and f3 along this path, so angle between them will be theta 2 between f1 and f3. The similar way, this is f4. f4 will be f1 and f2. So f1 and f4 angle between them f1. But in this case, there is no axis part. In x-axis case, we have taken the direction of measurement of angle in the anti-clockwise or positive direction. But this is not in axial case. So in this case, two vector f1 and f4 will be this theta 3. So it will not to measure the anti-clockwise or clockwise, but angle between them shortest angle. If two vector, suppose one is along this direction f1 and another is f2. So angle between them will be theta, not the larger angle, but it will be smaller angle, less than 180 degree always. So angle between two vector always less than 180 degree, and it will be not that means the anticlockwise and clockwise. But in axial case, in case of x-axis, to measure the angle between angle with the vector with respect to the x-axis, and in this case we need to measure the angle in anticlockwise direction as positive and clockwise direction as negative. So it need to be remember in this case of selection of angle.